Hi, welcome to today's webinar. My name is Mark Lambert, VP of Strategic Initiatives at Parasoft, and today I'm joined by my colleague Grigory Grigory, can you say your last name for me? I totally tripped it up.
Sure, Mark. My name is Grigory Trofimov. I'm a Senior Solution Architect at Parasoft. I've been here for about 5 years and really excited to talk about digital transformation, service virtualization, and Agile today.
Great, thank you, Grigory, and sorry for messing your name up. So as Grigory mentioned, today we're going to be talking about service virtualization, how to choose the right service virtualization solution, everything you're going to need to know, things that you should look out for that you need today, things that you're going to need in the future. And with that being said, let's kind of get straight into it. As I said, I'm Mark, this is Grigory. We're going to be jointly presenting today. This is what we look like when we're not COVID working from home. We're going to split today's agenda up into 4 areas. First of all, we're going to talk about service virtualization, how it can be leveraged to achieve continuous testing. We're also going to talk about some of the other use cases before we dive in there as well. Grigory will kind of talk through some of his experiences working with clients with service virtualization. We'll then talk about all of the different things, features, capabilities, your complete checklist of things that you will need for a service virtualization solution in the long term. And we'll break that down and focus on 4 core capabilities that you need for scalable automation and maximizing your ROI of your service virtualization initiative. At the end, we're going to give you a couple of links about how you can get started today. We'll talk about Parasoft's service virtualization solution, the community edition version that's available free, and you can just basically register your email and start playing immediately, as well as we'll talk about the white paper of kind of supporting today's webinar, which will kind of break down into even more detail. So with that being said, Grigory, why don't you kick us off and talk about some of the use cases for service virtualization?
Thanks, Mark. Yeah, so in the context of today's presentation, we're really going to be focusing on the quality assurance side. But before we dive into that, we do see a lot of applications of service virtualization across the industry, across the SDLC. For example, we're seeing it in development, in the prototyping stages with developer sandboxes. We're also seeing it on the operations side of things with sales demo environments, training environments, customer integration sandboxes, which really kind of enable customer success, customer satisfaction. But as I mentioned, today's presentation is really about testing and test automation. And here at Parasoft, we do talk about and think about testing a lot. And one analogy that we really like that really comes to mind is that of a faucet. Actually, I actually didn't really think about how good of an analogy a faucet is to software testing until about a month ago when we bought our first house, and we went around the house during the inspection. We turned on all the faucets, turned them off, made sure water's on and off, and everything looked good until maybe a few days after we moved in. At night, about 1 or 2 a.m., you start to hear that dripping noise, right? That drip, drip, drip. And that's really what we're trying to avoid from a software testing side and the test automation side. That's why we do continuous testing, is to be able to identify things like that as early as possible in the SDLC and really remediate those before they start to become a problem. Long story short, I have to get a new water heater tomorrow, right? And that's really what you're trying to avoid. And testing APIs is a lot like this faucet, right? An API on itself, you send a request, you get a response. It doesn't really do all that much, right? But the contents of that response is actually a result of a carefully orchestrated system of internal and external services and databases and mainframes. And so to truly validate a faucet, it means really to validate the whole plumbing system and make, to make sure it's not leaking, for example. And that's where service virtualization can really help. If you want to validate a faucet, you don't need to create the whole house. You can use service virtualization in order to simulate water flowing through that faucet, or simulate a water heater with a certain amount of sediment to make sure it doesn't burst the pipes, or simulate a bathtub and make sure that you have enough hot water to fill that bathtub in order to take a hot bath. So, Mark, how does this translate into testing?
Great. So thank you, Grigori. And yes, I can also draw parallels with my recent moving experience as well. And I actually also had a water heater issue, which we should share more stories. So let's applying this to testing. And the reason really why a lot of people look to service virtualization is because the testing challenge is just complex, and it's getting more and more complex. It's not just as most people would think about the front end. Obviously, the front end is critically important, right? You've got your mobile interfaces, you've got your web, you've also got the headless interfaces of the APIs themselves, and that opens up a whole world of additional challenges. Now, for you to be able to really test the application completely and test the user stories and the workflows completely, you need to be able to orchestrate test automation at the front end through each of these different channels, both front end, human, non-human channels, as well as validation with the back end. Now, if you have a successful test automation strategy, and we at Parasoft have obviously worked heavily in this area, and we have other webinars that are available through the platform, which talk about service, so not just service virtualization, but things like API testing, as well as UI testing as well. But if you have an effective test automation strategy, you can take those automated tests and actually leverage them earlier in the software development pipeline to do shift left performance testing and security testing. But if you're doing that, that actually exasperates a really big problem, which is that housing, all the pipes that sit behind the infrastructure. So you've got a whole bunch of back-end system dependencies that your test automation requires for you to be able to execute those tests continuously. And really, continuous testing is one of the goals with your test automation strategy, being able to not just run automated tests at the end of an iteration or at the end of a sprint, but be able to run them continuously as you're working on new functionality, as you're implementing your user stories. So the kind of challenges we're going to run into on those back ends, we're going to have systems which are third parties, which potentially are pay per play. Maybe it's you're leveraging some infrastructure from a credit processing agency, for example, and they have a shared test environment where you have access only during certain time windows. Maybe you don't have problems getting connection to the backend system because it's nicely Dockerized, it's cloud deployable. You can stand up an instance whenever you want. But the trouble is you can't control all of the behavioral characteristics. You can't get the right test data into the state. You can't get the system to respond in the negative ways that you need to be able to exercise corner cases. You also may obviously have multiple teams that you're dependent upon within your own organization itself. So, as organizations move towards a microservice-oriented strategy, lots of teams developing individual, small, granular components, but I might get stuck waiting for that other team before I can move forward. And then last but not least, really shifting left those performance tests and leveraging those earlier in the process, you may not have access to a backend system that can process the transactions at the rate you need to exercise your application. These are all typical use cases that we come across when we're talking about the application service virtualization for test. And here you can leverage service virtualization to simulate the behavior, the data characteristics, and the performance characteristics of your external dependencies. And this is critical that you wrap this along with safe test data as well, connecting both your front-end workflows with the back-end systems and how they're working together through the use of test data. And by packaging all of this up into an environment, we can really enable individuals to unblock themselves for ad hoc testing practices. So really enabling your test role to be able to control the test environment, to run through their test creation activities, or even ad hoc exploratory type of testing activities. But also those same environments become templates that you can leverage as part of a CI/CD pipeline. Stamping those out and deploying them within cloud-based infrastructure so that you can meet the needs of a particular test scenario. Now, one of the best practices when it comes to service virtualization is to not create big monolithic virtual assets, but to create numerous granular ones that can be very quickly stamped out and re-provisioned to satisfy your immediate test requirements. Then you're running your tests across these virtual environments, deploying and destroying them as needed, and aggregating all of those test results into one centralized location. By really packaging all of these things together, your tests, your virtual assets, the data, into an environment context that can be deployed and destroyed dynamically on demand, enables you to have complete control of the test environment and also be able to make continuous testing obviously a reality. Now, service virtualization has been around for a while, and there are a number of different solutions out there for you to look at. We typically would see they fall into really two categories. You have the lightweight tools, you have open source frameworks like Traffic Parrot, WireMock. Some people even potentially using Mockito for a code-driven framework. These are really neat to get started with. Typically, you've got ease of access because it's open source typically, and you can just kind of plug in and go. They'll cover simple use cases like HTTP-based transactions, for example, and you can customize them to your needs. The trouble is, obviously, that they're not really free, as you say, it's free in the short term. But as I have to start kind of maintaining or potentially expanding, they become a problem. Now, if I then think about the other category, this is where the enterprise tools fall. And this is obviously where Parasoft fits. The advantage here is obviously you're going to get a vendor-supported technology, which means that when there's a problem, you have somebody to pick up the phone and talk to. You're going to have comprehensive support of different protocols and use cases beyond the basic HTTP RESTful calls. And then you have the ability to really leverage that at a team and an organizational level. So there are these two different categories, and what you kind of need is the ability to be able to balance those two. But Grigori, I know that you're obviously working a lot with clients in these areas, and you'll see both of these two categories. Can you comment on that and kind of what you see that works and what you see that is a challenge?
Yeah, absolutely, and you really kind of hit the nail on the head there. With the lightweight tools, a simple problem requires a simple solution, right? And so the developers are often able to pick up an open source project and essentially solve that problem. But once you start scaling that solution out, that solution becomes its own project, right? It's its own project that you have to maintain. And if all of a sudden you want to scale it out to other teams and maybe they're using RabbitMQ and the library that you're using does not support RabbitMQ, what do you do now, right? Is it a whole brand new project that this team now has to maintain? There's no vendor support essentially to kind of help you underway as far as using these lightweight tools. On the other hand, with the enterprise tools, it typically requires a little bit more setup, a little bit more infrastructure setup and configuration. Additionally, you will see that enterprise-oriented solutions require time to get to know and understand how to use it, right? So professional services will be important there. Scaling it out to performance testing use cases, having to make sure that you have enough licenses for everybody, and bringing on additional teams can be a challenge as well. So at the end of the day, you kind of have to look at what you have today and what you're using, and more likely than not, you're going to want the best of both worlds, really, and a combination of something that's light, but also something that has all the sophistication and maturity of an enterprise tool. And so when you're evaluating all the different solutions on the market, typically you're going to come up with a list of requirements, which boil down to features and capabilities. And we went ahead and kind of broke those up into 5 categories of features and capabilities. There's ease of use, and whatever solution you choose here, it has to shine here, right? Without it, your team will struggle with adoption, and it's essentially being able to pick up a tool and just go. Optimized workflows means not having to keep redoing repetitive things, essentially, right? So your solution should have some intelligence to it, should be able to help you automate and templatize some of those workflows without having to recreate the wheel. Supported technologies, we're going to talk about this a little bit more in depth, and you have to consider all your edge cases. You have to consider all your primary use cases and your edge cases and all the different technologies that you're using across the enterprise. Automation, any modern solution should have automation in mind. So integrations with Jenkins, integrations with Azure, AWS, Bamboo, GitHub, etc., so on and so forth. You have to have CI/CD in mind. You have to have test automation in mind. And management and maintenance. So how does this solution scale, not only from a technology perspective, but from a practice standpoint? Does my architecture support collaboration? Does my solution help me maintain my testing library? So depending on the industry vertical that you're in, you may want to, you may check these boxes differently as far as what's required of a solution. For example, if I'm a financial institution, things that are going to be important to me are things like privacy, right? So ability to simulate authentication and security flows like SSL, OAuth, that's going to be critical. Ability to interface with legacy systems, right? In financial industry, we use Fix and Swift. So virtualizing those backend systems, that means I'm going to have support for those message formats. On the governance and the management side of things, there's likely a center of excellence that will want to define global configurations across the board. And so we need to have support for that. You need to have some sort of support for governance there. If I'm a telecommunications organization, I might have a different set of requirements. So I may want to validate that in a performance testing scenario, you know, when the new season of Mandalorian comes out, all of my households are able to stream the show. May want to validate that protocols, the common protocols for streaming like Kafka, WebSockets, AMQP, etc., have support for those. Web page virtualization is actually all very, very common today. I also may want to expose service virtualization as a service. And in that case, I really have to focus on the automation side of things and cloud support and make sure that AWS, Azure is supported, that there's images that make it easier to stand up those instances and don't result in downtime. And on the other hand, you know, if I'm a healthcare organization, my application might be integrating with many external services, many external dependencies. So having a stateful behavior-based simulation for complex end-to-end scenarios across multiple services may be important to me. Data security and ability to generate and isolate and reset test data might be important to me because I don't want to expose any customer data. And of course, in healthcare, we use EDI, so we'll have to have EDI support, EDI message format support for EDI virtualization. But just because I'm a healthcare organization, on the other hand, doesn't necessarily mean that I'm not going to need, you know, asynchronous API messaging or AI-powered asset creation. And so when sort of inventorying your team and your organization, you really have to ask yourself, what is my team doing? What is my organization doing? And the answer may be, well, perhaps we need a solution that really checks all the boxes. Mark, do you want to comment on that?
Yeah, I mean, so as Grigori just said, you know, there's a lot of things here, right? And you need to kind of think about what are the things that are required for my environment today, but also what am I going to need potentially in the future? Now, obviously, this is a bit of an eye test. Don't worry, there is actually a link at the end of today's webinar that'll actually take you to a white paper that goes through all of these in more detail. But what we're going to do today is we're actually going to break this down into 4 kind of key things that you need to make sure that you can maximize the ROI of your service virtualization solution. So we're going to go ahead and talk about how you create the assets in the first place, because obviously you can't use them unless they've created. We're going to talk about that breadth of technology that Grigori mentioned. We're going to talk about the architecture for deployment, but also utilization and management. And when we're talking about management, we're going to talk about change. And because your APIs, once they're done, they don't remain static. New elements get added, new services get added, and you want to be able to really understand how I can very quickly manage those changes that have been deployed into the system. So, Grigori, why don't you take us through these, and then I'll kind of bring it back together again, and we'll talk about what the appropriate next steps are.
Sure. So let's start with rapid service creation. What's really the challenge that we're trying to solve here? Well, as we're working and as we're developing our app, as we're testing our app, some testing time will inevitably be lost due to unstable environments. And it's not really, the whole environment that's unstable. It's some component, some data piece we don't have what we need there in order to do full end-to-end testing. And as a tester, I typically wouldn't have much control in that situation. That results in downtime. So if any tester, any developer can rapidly create a virtual service to remove this blocker, all of a sudden, this challenge goes away. And some key features to help with that are the ability to create services from a service definition. So service definition files are absolutely a best practice in the software development industry, in the API development industry, and a lot of times services may not even actually be fully developed, but there will be a definition file that defines those resources, those payloads, those schemas, etc. So being able to import a Swagger file or a WSDL or a fixed length data model and have the solution essentially create that virtual service for you and simulate that virtual service right out of the box, that will unblock you 80 to 90% of the time. Not to mention, Open API schema, Open API, the Swagger definitions actually even have examples now in their definition files. So you actually even have the data to start with in order to virtualize your service. Another common way to stand up a service rapidly is to capture traffic through record and playback. And there's a lot of benefits there because you get a lot of stuff up front, right? You get all the data from your recording, and you also get service logic. So your solution that you're using here should be able to look at that traffic and should make intelligent decisions about what that virtual service behavior should be, right? If it can look at the traffic and say, I recognize this zip code here. Perhaps I can create an intelligent correlation for my virtual service that will respond with this data for this particular zip code or for this particular user ID. Finally, all of this should be scriptless. Too often we see organizations struggle in SV adoption, essentially because they're recreating all of their service logic, with JavaScript or Python, simply because there aren't enough tools in the solution to support all that custom logic. And that really brings about scalability and maintainability issues when you're redeveloping those services, but redeveloping them, within the confines of your JavaScript libraries. That actually brings us to a breadth of technology, right? So what is breadth of technology? Well, there's a lot of stuff out there. There are a lot of common protocols like HTTP, MQ, TCP, FTP. But at the end of the day, your service virtualization solution should not care about what type of protocols you're using. You should be able to deploy the same service over MQ as you would over HTTP. So the solution should abstract that layer away from the message contents or the schemas or the data used by those services. If you want to deploy your service on HTTP2, you can deploy the exact same service on Apache Active MQ. There shouldn't be any limitations with regards to that. We also have a ton of different message formats to choose from, and your organization is probably using something like JSON and XML, but what happens when you're talking to complex backend systems? Does your solution support things like copybook, or we mentioned EDI? A lot of times looking at these systems will uncover even bigger ROI than you're already getting from your service virtualization solution. There are different application types, right? So different application types will also use different technologies. We talked about web services with REST and SOAP. On the IoT microservices side, we'll see things like proto-buffers and WebSockets and RabbitMQ. And finally, an SVE solution should be able to read a data source file. It should be able to read a CSV file, simple Excel table, but it should also be able to do more complex things with data. It should be able to query a database and pull data from there as well. And you certainly don't want to get too carried away there. With service virtualization, we're always looking to remove dependencies from your test environment, not add too many new ones, but you still need to have broad support across all of these technologies and have the ability to extend that support if something new does come along. And we're actually working with the customer right now, and they were using another tool for quite some time, and finally it's really kind of picked up. It's really taking off, just for them to very recently find out that it doesn't support sending attachments over SOAP. And so now they have to backtrack and figure out what other tools they can use in order to fill that gap, or whether or not they should just pivot and essentially pick a new tool altogether. And the reason you have to ask yourself questions like this is because at the end of the day, not having services available or having downtime in your test environments is a critical challenge, right? So comprehensive support for a rapidly changing landscape of emerging technologies really echoes this criticality. So using different tools can become very cumbersome, and being able to combine all of these technologies into a single Swiss Army knife solution is really a big deal and a must-have. So remember, when looking at service virtualization solutions, to take an inventory of everything that your enterprise is doing, everything that your teams are doing, again, everything that you might be doing in the future, because at the end of the day, choosing the right service virtualization solution will be clearer based on that. Now, if we talk about broadly accessible architectures, that means we've made it this far. That means we had a problem. We simulated some services. Great. Now what? Do we just leave that service there and walk away? Well, if we do that and then we come back a few months later and we think, well, that was a really powerful service, but how come no one else is really using this? Well, different users will have different requirements. And if we want service virtualization adoption to spread across our organization, then our organization needs to be aligned across its practice. Strategically, we all must decide. We will use service virtualization in development. We will use service virtualization in test. We will use it to increase our release velocity. That being said, everyone's different. Your community of practice, your practitioners will want it for ad hoc usage, right? They don't want to be involved in this huge initiative. They just want a simple entry point. On the other hand, if I'm a center of excellence and maybe have some more powerful users, I'll be tasked with a more broad initiative to digitally transform the enterprise. And with both initiatives, there needs to be a consolidated platform that reduces redundancy. If multiple teams are simulating different versions of the same service, you should try to avoid recreating the same service, as there may be an easier way to achieve the same result. Additionally, we may want to implement some centralized authority. What are these services that are being created anyway? Who's creating them? Your solution should tell you that. It should tell you how those services are being consumed and how they're being used. It should enable adoption, and the barrier of entry should be low, but the power should be great. And a good solution should have a browser-based client. It should have a browser-based client that serves as an orchestration and governance platform. It should be light. Any user can access it without installing anything. On the other hand, you may have the more powerful desktop users with much more complex and granular use cases. And all of that needs to work together. All of that needs to enable collaboration and link together, so users can search for existing services, deploy and redeploy services, clone sandboxes, secure their work and lock their work and prevent it from others modifying their work. And if that does happen, to be able to roll back those changes and check work in and out of source control. And that's actually very important as well, is when you're looking at these service virtualization solution, make sure you have a solution with native support for source control. So you don't want to find later on that you can't support your versioning workflows with your existing service virtualization solution. And last but not least, change management. So at Parasoft, we work with many service virtualization initiatives, and there's one particular story that really captures the need to focus in this area. One of our customers is well underway with their service virtualization and test automation and API testing automation, and doing very, very well. But one of their challenges is that they have a partner API, a third-party API that they're virtualizing, and every single time a change would occur, their partners would send them an email, they would send them an updated definition file, and let them know that the service should be online in about 2 to 6 weeks. Well, without access to that service, without data for that service, the team's really not able to make the necessary changes to their tests, as well as their virtual services. So they just kind of put that project on a shelf for a few weeks until that endpoint becomes available, and then they can go back and update their assets. What they did not realize at the time is this challenge is actually an opportunity. It's an opportunity to understand the changes that occurred in the service and actually implement some of those changes prior to that service even becoming available with their service virtualization solution. Because a good service virtualization solution should allow you to automatically perform things like change impact analysis, which will identify how the differences between the two versions of the service definition impact or simulated services. A mature solution will allow you to map those changes and create a template that can be used to update the virtual services or your tests, and prototype and update those assets against it. By the time their partner would bring those services up in the 2 to 6 weeks, they were able to use these templates and refactor all of their tests, and they would essentially be good to go. So they could just plug in, and all their tests would work against the virtual services. Their virtual services would be in compliance with the new services that were just brought online. So this change impact analysis, along with the ability to map those changes based on service definition, enabled them to shift left their test automation practice. But changes can actually occur in test data as well. And being able to understand the response of a service and how that maps to its underlying data will also help you maintain the SV initiative. And data usually reflects the complexity of the service itself. So when identifying the impact of change in the data, it's important to model the shape of that data, where you can visually understand how it's changing, and in the same tool, be able to subset or reshape that data, or simply generate new data based on a new set of business requirements. In this instance, it's also important that the solution maintains sort of a modular approach to service virtualization. So if there's any changes in the schemas of your services, that doesn't affect the data, you shouldn't have to refactor the data. On the other hand, if any changes to your requirements in the data occur, you shouldn't have to touch the virtual service or the shape of its responses or its schemas. So make the changes where they're necessary and avoid having to make unnecessary changes where it's not. This will always increase maintainability of those simulated services, reduce rework, and enable reuse. That being said, Mark, anything you want to add here?
Well, yeah, I mean, obviously that was a lot to take in. So let's kind of like bring it back up again for a second and just talk about these 4 key areas. So rapid service creation. Basically, you want to be able to enable the team to create an asset quickly. That means being able to create something that not just mimics a single transaction, but also stateful behavior. and the ability to be able to record a sequence and be able to replay that in an easy way is going to be critical for you to get going. But you know that that's not going to be the end goal. You're going to need to make sure that that asset is that you can edit it, that you can work it, that you can put in some of the elements like data learning, which was one of the things which was on the big eye test earlier. Right, so get going quickly. You then got breadth of technology. I think we kind of hummed that one or drummed that hit that drum pretty hard today. But basically, yes, you want to get going quickly with the things that you need today, which are in most cases HTTP-based transactions. But also, you're going to have some problem children. MQ, you're going to have mainframes, you're going to have the backend components that you want to be able to support ultimately as well as you move across the organization. So you need to keep an eye to the future. Accessible architecture, mixing both an environment where you have a lot of power for creation for your power users, but also some kind of interface which gives you the ability to very easily leverage those assets as well. We talked about thin client ecosystem for controlling the test environment, but also you want to be able to do some basic editing capabilities in there as well. So the people that want to do that light touch have the ability to be able to access the technology. And then last, obviously, change. And this is really important when you're looking at a modern API-driven architecture, where you've got a lot of microservices, you've got a lot of incremental quick deployments and changes. The most effective way for maintaining a continuous testing practice is having the ability to virtualize those and prototype those services as quickly as possible. Now, what I will say is there's a lot of detail there. So if you've got some questions, please go ahead and add questions into the dialogue. We're going to go and jump into some of those in a few moments. But let's kind of bring it home and talk about kind of stepping all the way back and say, well, why are we doing this in the first place? We're doing this in the first place because your test environment is unstable or unavailable or uncontrollable. And we can break these down to four things, what we call the ABCDs. First of all, accessibility, third-party systems, maybe something that's not ready yet. Behavior, not just the functional or data behavior, but also the performance characteristics as well. Can I simulate what would happen if my backend system responded very fast or very slow? C would be cost. Obviously, a virtual asset costs a lot less to deploy and manage than a backend infrastructure, especially when you're talking about a third-party ecosystem that potentially is some kind of pay-per-play. And then last but not least is data. And Grigori touched upon this in that last section, but really many organizations struggle with test data within their test automation strategy. The ability to be able to not just kind of have multiple teams working with the data. So, you end up in this shared sandbox world, which kind of feels a little like Jenga. Hey, I've used this data record. I hope that doesn't mess up somebody else's test automation and bring the whole thing crashing down. But also when you're doing things like performance testing, you may have like a set of data that you want to have available so you can burn through it. The IRS, for example, that's one of their use cases where you want to preload a whole bunch of taxpayer information, and then you burn through that data. You can't process tax records for an individual more than once. So you have to set up that data and make it available in a way that allows me to burn through my performance testing. So in summary, at a very high level here, there are several things that every service virtualization tool must have. Ease of use is a core capability component. Maintenance and management you will also need to be thinking about because it's not just a one and done. And then for you to be able to maximize your ROI, you need to be able to focus on the things that we just talked about. Creation speed, breadth of technology, architecture for access and deployment, and then also change management and test data. Now, obviously, Parasoft Virtualize checks all the boxes. Parasoft Virtualize is a recognized leading technology for service virtualization, and it is on that right side. It's an enterprise-grade product. The great thing is that we offer a community edition version as well. That community edition version enables individuals to get up and going within their desktop environment. It supports the protocols that you would expect within a lightweight tool, such as HTTP-based protocols, but it also sets up a framework for you to be able to expand across the organization into the more exotic asset types, and also gives you the ability to create assets on your desktop that can be then deployed within the server-based ecosystem that Gregory was talking about. If you'd like to go into more detail around this topic, there is a white paper that's available online, two QR codes here, obviously, and that will actually go through a lot of the things that Gregory talked about today in more detail. Okay, so with that being said, let's take a look at the questions. We have time for, I think, probably 3 or 4. So I'll pick up a couple that have come through already. Please feel free to send them in more. Okay, so how have others quantified the ROI of service virtualization? That's a good question, because we talked about what you need to be able to maximize it, but we didn't talk about how to quantify it. Gregory, do you want to touch upon that one first, and then I'll kind of pick up the ball from there?
Yeah, absolutely. I mean, you're quantifying ROI. You always have to look at time, right? The time that it takes for to stand up an environment, for example, and the cost of standing up that environment. It takes developer time. It takes DevOps time in order to do that. Additionally, you know, if your test environment is unavailable, which is often the challenge that we're trying to solve with service virtualization, that means, you know, you're only able to do 10-20% of the test or test automation that you'd like to do, right? So that's immediate ROI in just being able to do more testing with less time. Mark, obviously you've worn many hats. You could probably provide some additional insight into that ROI as well.
Yeah, so there's actually probably a couple of other areas that I'd focus on with ROI as well. Firstly, the cost of infrastructure. Especially if you're talking about an external dependency. One of our clients leverages a trading platform, and that trading platform, if they want a test instance, in essence, works out to be about $500,000 a year between cost of software and then what it takes to manage that test instance, and then that becomes siloed. And teams have to kind of manage their time window to get access to it. So rather than creating multiple instances, you could actually leverage service virtualization to block the teams earlier. It doesn't get rid of the need for that external dependency, but it certainly gets rid of the need for lots of test instances. Now, that's the first thing, would be kind of cost of infrastructure. And there's a couple of other plays there as well. The other is actually we did a webinar on ROI of test automation, and that's also available on the platform. And there's a couple of techniques which actually apply to service virtualization as well. One is the ROI of test automation itself. So your whole point of service virtualization, or one of the key points of service virtualization, is to be able to enable continuous testing and be able to run your test automation all the time. So just by the fact that you can now run your test automation means you're not having to try manually testing everything every sprint, every day. So you get, obviously a value proposition just from the time savings versus manual testing run. Now, the other part of it as well, we also touched in that webinar, was actually the ROI associated with defect identification and finding those defects earlier in the process. So SV, you can simulate a whole bunch of different corner cases, which gives you the ability to find an issue before it hits production, or before it hits perf, or before it hits integration or SIP environments. So the idea is, if I can find a defect earlier in the process, I reduce its cost because it's easier to identify it, for example, at unit testing than it would be at integration. And again, that webinar talks about that. There's actually a paper that will be available soon as well, which talks about a couple of different ROI calculations. So I think there's a whole topic there, and I think we do touch upon that in the other webinar, but certainly when you talk about service virtualization, there are a number of great advantages there too as well. Okay. All right. So let's go ahead and look at the other questions here. Okay, don't worry, that was a little, we only have a couple of minutes. So let's actually pick, okay, let's see if we can do 2 more. Can I virtualize the mainframe? That one always comes up, especially when you start talking about breadth of protocols. I'll do that super quick. It's like, yes, but it depends. So if you're talking about off mainframe virtualization, so I've got an open system, I've got like my microservices or something that's consuming data from the mainframe. It's probably doing that over an MQ-based protocol. Is probably communicating copy bucks. So yes is the short answer, is you can certainly virtualize this. It depends where you're drawing the line. If you're drawing the line at the message communication with the mainframe, my short answer to that question is yes. Now, the depends is if you're trying to do on mainframe virtualization. And that's where it becomes more tricky, because you're trying to not put too much software on the mainframe. And when you're talking about, if you're trying to intercept communications between CICS regions, for example, this is where I'd probably look at more of a technology like BMC CompuWare's Topaz product for doing on mainframe work. But service virtualization, definitely, as it says in its name, is service virtualization. So, emulating the service calls to the mainframe. Would you add anything to that, Grigori? We have one more question I think I'd like to pick off.
Sure. I think that answer captures it.
Okay, cool. And so let's take one last question, and it's like, my organization has adopted SV, but we are struggling to scale across the organization. Okay, what are the best practices or recommendations? Do you want to go through that one, and then I'll kind of like add more as if that's needed?
Sure, and that actually, I mean, that's a great question. It maps directly back to the sort of the four core things that we kind of looked at to maximize your ROI, right? Rapid service creation, ease of use, broadly accessible architecture. So those types of things will enable different types of users with different requirements to pick up a solution and be able to leverage that solution to solve their problem immediately, but also to share that solution across the organization with others. And that's really what being able to scale is about, is making these tools accessible for everyone. And that may mean essentially having something that individual users, individual teams can install directly on their desktops, or it can mean something that you expose as a service, right? We talked about service virtualization as a service, being able to stand up, deploy and destroy containers, Docker containers within Kubernetes clusters that everybody can go in and either leverage an existing virtual service or deploy a new virtual service, or have an environment instance be deployed for a specific set of tests and test suites. Those will enable adoption. Those will enable scale throughout the organization. And if we were looking at vendor solutions, right, or enterprise solutions like Parasoft, of course, there's other things that we do in order to enable scaling, not only from a technology perspective, but as a practice. And that's having access to learning management systems, forums, vendor support, et cetera. All of those things in combination will help scale the service virtualization initiative.
Okay, thanks. Yeah, I think you touched upon everything. I don't think there's anything that I would add to that. Okay, I do see we have a couple of other questions that have come in as well. Let's see if we can pick off one more. Okay, there's a question about Hill and Sill. I'm not following the question though, so I think we'll have to follow up with that one offline. And then there's a couple of things about underlying technologies. Yeah, so one question around industry-specific protocols, so a TCP/IP protocol. So basically, you can extend a Parasoft solution. You can extend to encapsulate other protocols. The advantage of that versus creating your own tool, which you would basically have to do to support a very specialized protocol like that. The advantage is you get to leverage all of the ease of use capabilities of Virtualize, and actually those assets can also be re-leveraged for doing API testing with service virtualization as well. So if that's an interest you, please kind of reach out to the team. Okay, I think, in the interest of time, I think we're good. We've got a couple of other questions. We'll follow up with those offline. But Grigori, thank you for your time today and letting me kind of totally mess up your name at the beginning. So Trofimov. So I'm trying to practice that. So, all right, thank you very much, everybody. Have a great day. Be safe, and I look forward to seeing you on the next webinar.
Thanks, everyone. Thank you, Mark.